Okay, we are recording and we're underway. So, welcome back, everyone. It's good to be back after last week. Feeling a lot better now, so ready to go. I guess last week we focused a lot on Ethereum and, it's kind of how Ethereum works, its advantages and disadvantages, comparing it to Bitcoin. And then we started looking at the broader ecosystem around Ethereum and around, in particular, decentralized finance. So what I wanted to do to start off today was kind of finish up our conversation on decentralized finance and show off a few more things that we can get to last week. Sorry, was that? Not sure if someone was asking a question, but I could just hear some noise. Okay, I'll just carry on. Also, if you've got questions, you can also put them in the text chat, which I'll keep open if that's easier. Up to you. So yeah, we'll talk a little bit more about decentralized finance. And then kind of the main focus for today is to start to talk about the different types of tokens that we can create on the blockchain and on Ethereum. And then kind of do a practical demo of how you would kind of create your own token contract, so your own cryptocurrency. And then how you would use that. And it uses the MetaMask wallet that we were looking at last week. So if you've got that already installed, that's great. And then we'll start to look at some other tools for interacting with smart contracts as well. So that should take up all the time. If not, then we'll go to some other cool stuff as well. So firstly, I just want to quickly start off with an update on something I talked about last week. We were looking at the Ethereum network, and I was describing it as a kind of global network of nodes where, we looked at it at a map like this, and you can see that people are running Ethereum nodes in the US and in Australia, in India, in Europe. But as of this week, so between last time we saw each other and now, it's no longer a global network. It's now an interplanetary network or a interspace network. So there's this company called Space Chain, and they've just launched the first Ethereum node into space. So it was on board a SpaceX rocket. This company has previously launched a Bitcoin node into space. So Bitcoin was already running on the International Space Station or on a satellite. But now Ethereum will be running on the International Space Station as well. So that's quite cool. You might submit a payment to someone that gets processed on the International Space Station. So now, on to decentralized finance. So I think last week we talked about kind of the exchanges that were available. So exchanges for moving money into Ethereum from US dollars or Australian dollars, moving it out of Ethereum, and then transferring between different cryptocurrencies. So you can go Bitcoin to Ethereum to Litecoin to Dogecoin and so on. And then the other thing we're looking at is, bring it up, the kind of extension of a centralized exchange to a decentralized exchange. So as a quick summary, that was the centralized exchange is like a bank. So someone like Coinbase or Kraken, it's a registered company. They have traditional server software that does all the trading for you, and they're a single point of failure. So if you want to transfer your money into Ethereum or to Bitcoin, you're kind of fully relying on that company in the US or that company in India to manage your funds correctly, to give you a fair rate and to play by the rules. It also means that if they have a software outage, for example, you're kind of stuck, you can't access your funds at all. If they go bankrupt, you might lose money and so on. So there's a lot of risk inherent in any centralized system. And that was one of the motivations for Bitcoin and for other blockchains being created. How can we take these centralized systems, banks, and then make them kind of decentralized and fair and open to everyone in a technologically verifiable way? So one of the most common use cases now is to take those centralized cryptocurrency exchanges and money exchanges and put them on the blockchain. So what we're looking at here is Uni Swap. And I tried to show this last time and it didn't work, but I've tested it out and I think it's working now. So Uni Swap is one of the most common decentralized exchanges. Now, if we look at the charts, for example, you can see that they've currently got nearly 2 billion, I think this is US dollars, locked into the Uni Swap kind of currency pool. They've done in the last 24 hours, $682 million worth of trades. And they control, or they can trade all of these different types of tokens. So Ether, the native currency of Ethereum. You've got your, what else have we got? Wrapped Bitcoin, essentially. You've got some tokens or some cryptocurrencies from different projects like Chainlink and even Uniswap itself. And then you've got some stable coins, which we saw stay at $1 US or whatever else it's pegged to. And the cool thing is that this is all running on Ethereum without a central person controlling it. So the party that's in control of this whole exchange is just a set of smart contracts that gets run on all the nodes around the world so that everybody can agree on what the price of an Ether is compared to a US dollar and so on. So what I'm going to do is just show you how to use Uniswap first. So if you remember last week, we installed this wallet, MetaMask. So I'll just log back into this. And what we also did was we connected to the Ropsten test network. Now you might remember that in Ethereum, we have kind of the main Ethereum network where one Ether is worth, say, $4,000 at the moment. But then for people to be able to develop new smart contracts and to test out technology, and for developers to practice, upgrading the Ethereum network and so on, they also run lots of different test networks, which act mostly the same as Ethereum, but where Ether is free. So you can do all the things that you would do on the Ethereum mainnet, but for free. So we're connected to kind of the biggest and the most common test network, which is called Ropsten. And we set up our accounts last week and we funded them with some test Ether here. So I've still got 0.9 Ether now. What I'm going to do is, what I want to do essentially is swap my Ether or some of my Ether to any of these tokens here. So say I might want, what have we talked about? Okay, let's look at DAI because we'll talk more about DAI in a second. DAI is a stable coin. So it's one DAI is always mostly equal to $1 US. And it's quite a common and well-regarded stablecoin. And let's say I want to buy 10 DAI. So that's worth about $10. Hello in the chat. So if I type in $10 or 10 DAI here, please add Momita. Oh, have I forgotten someone? Let's see. Disabled the waiting room. She might need to try joining again. Let's just wait for her to join. Hopefully she'll join soon. I'll just continue for now. And let me know in the chat if there's anything else I need to do to let her in. So, okay, so we're trying to trade for 10 DAI. Now to do this, we could go through Coinbase, or we could go through Kraken or someone like that. But traditionally, they would take a fee, a percentage on top of this trade, so you wouldn't get the best price possible. And also, there's all those disadvantages of it being a centralized exchange. So what we've done here is by putting in that we want 10 DAI, the smart contracts, which are running on Ethereum, have calculated that 10 DAI is currently worth 0.0039 Ethereum. So now if I connect to my wallet, so I'll just click connect to a wallet, I'll go MetaMask. Now we've connected to Ropsten, so we can see we're no longer on the main Ethereum network. And we can double check our address here too. So our address, which is our account, our name on Ethereum, starts with 0xAA. And we can see that our account 1, which has 0.9 ETH, also starts with 0xAA. Hello, Mimita. Welcome. So let's see if this works now. I've put in my 10 DAI and I'm going to trade 0.27 ETH. So on Ropsten, there might be a different rate. And all I have to do to start interacting with this decentralized application is I'll just click this swap button. So what it's saying behind this user interface is that if I click this confirm swap, it's going to convert my request here into an Ethereum transaction. So whereas Bitcoin, obviously, your transactions are essentially, Cadle sends Bob $5. It's as simple as that. It's a currency transfer. With Ethereum, your transactions can also be a smart contract call into a smart contract function. So here, whoever wrote Uni Swap, so the authors of Uni Swap, in their smart contract have written, say, a swap function. And when I click this confirm swap, all this data here, so the rate that I'm paying, the current time, and so on, are bundled up into that transaction and sent to that smart contract. So I'll click confirm transaction. You'll get this notification pop up, and it says that this is a multi-call. So I'm sending a transaction with data, not just a currency transaction. If I click on my data here as well in the MetaMask window, you can see the actual data that's been packaged into my transaction. So it's all this kind of hex binary data. This obviously doesn't make much sense to us, but the machine knows how to interpret it. I can see, as well as the transaction that I'm making, I can see how much it's going to cost me in terms of network fees. So if we recall from last week, every interaction you make with a smart contract costs a certain amount of gas. So it might be really cheap in terms of gas to add two numbers together or to subtract two numbers, but really expensive to store data in the Ethereum blockchain. And so different things to do in the smart contracts, all is added up and you get your kind of gas total. Then it's multiplied by whatever gas price you set. So by default, MetaMask has set us to pay 10 GWay, which is a really small amount of Ethereum. That then is multiplied with the gas that this transaction will take to run the smart contract, and we end up with our gas fee here. Then the total amount of Ether that we're sending is equal to the gas fee plus the 0.027 Ethereum that I'm sending to the contract in exchange for the DAI stablecoin that I'm getting back. Now, you'll also recall last week we looked at the Ethereum gas station, and we saw that if you want nodes to mine your transaction or to run your smart contract calls faster, you can bump up this gas price. So what I'm going to do is just set it to 90, because the reason I've done that is I know at the moment that the Ropsten test network is quite slow for low gas prices, just because I've been trying it out this week. So I'll just bump it up, and hopefully that means our transaction is quicker. You can see that because I'm willing to pay a higher price, my gas fee has gone up, but it's worthwhile because it'll be faster, essentially. So I click confirm. We can see that the transaction has been submitted. And if I open up the transaction, this is just the same Etherscan interface that we're looking at, but we can see the transaction details here. So hopefully that will mine soon. We should also be able to see Here we go. I think that's worked now. Success. Okay, cool. So we can see our transaction has gone through. We can see that it was included in this block. This, I think it's up to 10 million blocks. So we put that. Then we've also had 3 confirmations on our transaction. So if you recall back to our first kind of call about Bitcoin, a confirmation is how many blocks have appeared in your blockchain after the block that your transaction was included in. So if I look at, say, just a quick diagram. Just load this up. That's so small. Okay, so you can see here that this is how an Ethereum blockchain or a Bitcoin blockchain might look. So we've got this chain, 2333, then another block, 2334. And then we have this fork in the chain. And the reason that happens, or the reason the fork appears, is that 2 different nodes around the world might have created a block with a valid proof of work proof at the same time. So they've both sent their blocks around the network. Half of the nodes have chosen to include this block A. Half of them have chosen to approve block B. So we've got this little fork. Then, as more blocks have come around the network as a whole has to decide which chain to follow. And we end up with this kind of unified blockchain history. Then the block that was not chosen, so block B here, is essentially crossed out and deleted. So if you had a transaction that appeared in block B, but not block A, then later on that transaction might disappear from the blockchain. So it never really took place in terms of the shared database records. Now, the number of confirmations of a transaction in block A here is the number of blocks in the chain after it. So here there's been 1 confirmation. And the more confirmations of your transaction, the more likely it is that it's been included in the global database. So in Ethereum, we like to wait for six confirmations as a kind of a minimum before you can say that the transaction has definitely been included. If I look now at my transaction, we can see we've had 26 block confirmations. So we're pretty much guaranteed now that our transaction will remain in Ethereum from now on. So that's quite cool. Now, if I go back to Uni Swap, I also get this handy little button here that says add Die to MetaMask. So remember, Die is the currency that we've transferred for. If I click this button, MetaMask will let me add it to my wallet. So I can see that I've now got 0.85 Ether, but I also have 10 Die in my wallet. And I can actually send and swap this Die with other people, just like we transferred Ethereum. And we'll talk about how that works a bit later on today. So are there any questions about Uniswap? It's kind of a basic overview, but I wanted to show you how a decentralized application works from a user perspective. Okay, cool. So what I will do now is talk a little bit about what DAI actually is. So we've swapped for DAI, and we've seen that if we look at the DAI price over time, so if I go to Coinbase, for example, which is a centralized exchange, if I look at the all-time price for DAI, we can see that generally it hovers at about $1 US. So an Australian dollar is worth slightly less, which means that this looks like it's more than a US dollar, but you know, this is about a US dollar. Let's see if I can find the DAI to USD chart. It should look a lot better. So let's look at the 1 year. We can see that the price has kind of stayed between, what's the maximum here? $1.04 and the minimum of 99 cents. So it's remarkably stable. In general, there's kind of two ways that stable coins work. One is that whoever owns the stablecoin contract or whoever creates the stablecoin contract is responsible for creating new coins, and then they kind of hold in reserve, or they hold to back it, actual currency. So say I wanted to start a new stablecoin called Cable's dollar that was always equal to $1 Australian. I might have a bank account in Australia that has 1,000 Australian dollars, and then I would create 1,000 Cable's dollars on the blockchain so that it's kind of pegged 1-to-1. And generally that's kind of called the money that you hold in the bank account is called the collateral. So it's essentially saying that Cable's dollar is backed by Australian dollars in a bank account. And if we look at something like Tether, for example, which is the most widely used US dollar stablecoin, it's always equal to $1 or $1. And you can see that they claim that every Tether token is 100% backed by cash or by investments. So it stays at $1 because people who use this smart contract, this cryptocurrency, believe the people who have created the contract that they actually have 100% of the US dollar value in a bank account somewhere. The same is true for USDC, which is kind of the other major stablecoin. Now, USDC is held by, or is started by a company called Circle, which is a US-based company. And they, again, hold that cash in reserve and then issue USDC on-chain, which people can use in place of US dollar. Now, you probably can also already see the problem with these two currencies is that, yes, you're using a stable coin on the blockchain. So you do have the advantages of blockchain in terms of being able to transfer it to anyone at any time and not being able to spend the money twice and things like that. But what you're really doing is you're trusting these two companies, Tether and Circle, to hold the cash in the physical bank account that they say they have. So we're trusting Circle's claims that they have $23.7 billion to back this stablecoin. But really, there's no way for us to verify that without actually looking at their bank account. So Circle is very trustworthy. It's based in the US and it's regulated. So people are generally pretty trusting of Circle, of the USDC. But Tether, on the other hand, is quite controversial. So they claim that they have fully 100% backed currency, but there's some controversy about whether they actually do, because enough people believe Tether. The price of one Tether is still $1, but there is the risk that they are, creating more Tether tokens than they actually have in cash, in which case it's not really a full stable coin and it's not really a legitimate stable coin. So that's something to keep in mind while you're dealing with stable coins that are kind of centralized in this way. They're backed by a certain company. As an alternative to these centralized stablecoins, we can also have decentralized stablecoins, which are entirely run by smart contracts. So just like we had the centralized exchange, which was moved onto the blockchain in the form of something like Uni Swap, the Die token, so the one we just traded for, is actually fully governed by a smart contract. So there's no company behind Die that holds $1 in a bank account for every one Die. It's all run by smart contracts, which, because Ethereum is an open and transparent system, you can actually have full visibility to, and you can see the logic of how it works and make sure that it's following the rules. And right now, we're looking at the Die contract, and we can actually see the link to that address, the contract address. If I copy the contract address, so this is the address on the Ethereum blockchain where the Die currency is stored. I can go to Etherscan, or I can paste in that contract, and I can actually have a look at the transactions and things like that that are going on. So we can see that this contract is tracking the Die stablecoin, which is currently $1. I'll make this a bit bigger too. We can see all of these transactions that are going in and out of the smart contracts. So these are all people who are using DAI. So you can see who's transferring what and so on. You can also actually see the contract itself. So this is the contract code that governs that DAI stablecoin. And it's quite a complicated system. So this is just one part of it. This is the token itself, but there's a lot of logic that's required to make sure that it stays at $1 without having a backing currency. So it's a really very impressive application of smart contracts to be able to stay so stable as we saw here, but without any bank account backing it up. And instead it's kind of secured by people loaning different cryptocurrencies into the system. So on. So if I look at, let's look at the system. Just want to see the, yeah, okay. So one of the great things about a decentralized application like DAI is that there's no single person who controls how the currency works. Now in DAI, what we have is essentially a community government. So everybody who holds DAI or who holds or who helps secure the smart contract, so by funding it with loans and by using it and things like that, has the chance to vote in various governance decisions. So people might want to, say, raise the amount of DAI in existence. Because currently we can see that there's 5 billion issued. They might want to raise that ceiling, for example. So just through this kind of another decentralized application, they can actually vote on these decisions, and then the system as a whole, based on what the community wants, will make that change. So if we go to, say, the polling votes, you can see these are all the kind of active votes for the community at the moment. A lot of these don't make much sense, but what have we got? See here, they're saying that they might want to use the link token. So it's another type of token to back the DAI currency and so on. So you can kind of vote yes or no. And we can see the current vote. So 99% of people are in favor of this so far. So in 1 day and 5 hours, this will be accepted and go through. So that's quite cool. As opposed to, say, trusting the Tether company to make that decision for you. You can also, as part of this MakerDAO organization, which runs DAI, the community also funds kind of budget grants to developers who are working on the system, to people who are building projects that use the DAI stablecoin and so on. And that's just done by a vote, just like all the other changes. So here they've put kind of a proposal for the budget distribution. So who will get how much DAI? And then the community is going to vote on this and decide where it goes. So, and you can kind of get that fully transparent overview of who's getting what, and then do a democratic vote on it without the need for a kind of third party to step in and make that decision. So DAI is a really, really cool decentralized application. Okay. So what I want to show next is, if I get my link, for kind of a broader overview of the decentralized finance ecosystem. So what's currently being used on different blockchains, but mostly Ethereum. There's this website called DeFi Pulse. And what you can see here is all the different decentralized finance projects that are currently being run on the blockchain. So all of these projects here have no kind of company that's running the servers. It's all done by smart contracts, and they fulfill a bunch of different functions. So one of the cool things we can see is the total US dollar value of decentralized finance right now. And we can see that it's currently a giant application for Ethereum. It's the biggest application for Ethereum by far currently. So we can see there's 58 billion US dollars currently locked into decentralized finance on Ethereum. We can then see that a breakdown by project type. So you can see that Maker here, which is the DAI stablecoin. This is the the organization that manages the DAI stablecoin, is currently the second biggest decentralized application. We can see Uni Swap, that decentralized exchange, is number 5. And we'll kind of talk about some of these other categories as well. In terms of terminology, DEX, so DEX stands for Decentralized Exchange, if you're wondering what that is. Kind of the biggest categories, so they've got 5 categories here, are firstly decentralized exchanges. So we've seen how that works. You want to take out the middleman who's helping you trade currencies with each other, and you do that all through smart contracts. So that's one of the major applications. Probably the biggest decentralized finance application at the moment is in lending. So this is just like when you go to a bank and you want a loan, right? So you take the loan from the bank and then you pay it back later with some interest applied. Companies like Compound, I go to the Compound website, have built a smart contract that manages these loans for you. And you can see they're currently lending out $12 billion worth of loans, which is just crazy. We go to the markets here, and you can see that $5 billion is currently out to people who've just taken out loans with a smart contract. You know, they haven't had to go to the bank and convince the manager there that they need this amount of money. They can borrow it from the smart contract in any currency they want. So 51% of them have chosen to receive their money in DAI, just that token we're talking about. And then later on, they'll pay that back with a certain interest rate, which is calculated by the contract. So here, 4.12% in annual interest for DAI, for example. Then you might ask, where does the money to actually pay these loans come from? It comes from just other people who use the Ethereum network who want to lend out their money to other people in order to get that interest back. So you can see if you put in DAI to this system, so if you have $1,000 and you want to lend it out and make some money, you can actually put it into the Compound smart contract yourself, and you'll get back 2.46% interest every year. So you kind of make money like that, and you're also helping people who want to borrow money. So it's quite cool. Then just like Uniswap, you can interact with this through a decentralized application, which you just connect with MetaMask. Just like with Uniswap, it'll say we're connected to the Rocksteady testnet. So we're not dealing with real money. I'm not sure if this app actually works on the testnet or not, but that's all right. I switch to the main net. So here we go. And you can actually, you can lend out money if you wanted to. So I could enable this right now. However, I have 0 ETH, so I can't do that. Now, if I want to, where is my? And all of these decentralized applications, they usually publish their smart contracts on GitHub or somewhere else like that, like GitLab. And you can look at the contracts and you can actually see all the rules that go into that loan. So maybe you want to know how the interest rate is calculated. You might look at that interest rate model smart contract, and you can read the contract and see how it works. This doesn't actually have any of the logic there, but we can find that somewhere. Not sure where. I haven't really looked at these contracts. Yeah. So it's all it's all open source, and you know exactly how the loans are calculated, which is really cool. So back to DeFi Pulse. Some other areas for decentralized applications are derivative market. So something like Quenta, this is a different type of trading. So instead of trading currencies with each other, you're trading what are called derivatives. We don't need to go into too much what those are, but it's kind of one step removed from trading cryptocurrencies. So people use it to bet that Ethereum's going up or down, for example. You can kind of make money by betting correctly. That's the derivative section. You've got payments. So people like the Lightning Network, which runs on Bitcoin, enables really fast payments to people. That is an improvement on, say, the Bitcoin block processing times. So remember, when we were making a transaction on Bitcoin, it might take up to an hour for it to be confirmed enough. If you use the Lightning Network, you pay a little fee, but it goes a lot faster. And then there's finally, like, say, an assets category where there's various different applications all kind of grouped into one thing. But what I'd recommend you do is go to this website, DeFi Pulse, and just have a look at all the projects that are available. It's pretty impressive. And also check out the smart contracts if you're interested as well. Okay, so that's all I wanted to talk about in terms of decentralized finance. Are there any questions before we get on to tokens? Okay, cool. So let me close all these tabs. So far, what we've been dealing with are cryptocurrencies in general, and then tokens that run on the Ethereum network. And you'll see that Ethereum, a lot of the smart contracts on Ethereum are tokens of some kind. And a token is kind of a currency or an asset of any kind that's been represented by a smart contract. Now, broadly, they're broken into two categories. There are fungible tokens, which is what we've been looking at so far. So if I'll bring up a diagram. So this might make it a bit more clear. So we have two types of token. We have fungible tokens and we have non-fungible tokens. Now, what fungible really means is mixable. So the idea is that with a fungible token like a dollar, if I have a dollar and then my friend has a dollar and we swap our dollars with each other, then we're both still happy. You know, it's the same amount, it's the same value. So we don't care that that's swapped. So $50 in one bank account is exactly the same value as $50 in another bank account. You know, the dollar itself is mixable. It doesn't matter which dollar you have, it's still worth $1. So something like Ether, you don't have, say, Ether 1 and someone else has Ether 60. You both have one Ether and you can swap them and you won't care. You know, it's fungible and it's mixable. Non-fungible, on the other hand, are any tokens where if you swap them, you would notice a difference, essentially. So say you had two cars. I had a car and Elif has a car. They're both worth $20,000, but they could be different colors. They could be completely different brands, or one might have 100,000 kilometers traveled and one might have 50,000. So even though they're worth the same amount of money, they're not equivalent. And if you swapped our cars in our garages, we'd definitely notice. And that's non-fungible, you know, it's not mixable. Some of the examples they've got here are artworks, for example. So the Mona Lisa might be worth $10 million and a Picasso might be worth $10 million, but you can't swap the two without people noticing. Same with things like a house, other property like cars, and then CryptoKitties, which we'll talk about too. So fungible tokens are pretty understandable, I think. You know, we've been dealing with Bitcoin and Ethereum and all of those stable coins like DAI and Tether. That's all fungible tokens and we're pretty across that. Non-fungible tokens are a kind of really unique innovation that's come along with blockchain. So whereas these fungible tokens, you know, you use it every day in terms of dollars, what people have realized is that there's value in having tokens that can be traded without being mixed. So one of the first kind of uses of a non-fungible token was something called CryptoPunks. And I think this happened about, I don't know what that link did. I agree. So about 5 years ago, I think, someone created this non-fungible token called CryptoPunks. Now, each of the CryptoPunks, each of the tokens has a different little person attached to that token. So number 7804 has this smoking person, for example. So if you swapped two of our tokens, you definitely notice, they've got different images attached to them. But you can also kind of hold them in your wallet just like a fungible token. So I might own 3 CryptoPunks that are in my Ethereum wallet, just like an Ether or a DAI and so on. So you can see that people are still, trading these tokens with each other. In terms of the largest sales, this little smoking fellow, he got sold at auction this year. So he got sold at auction for $7.57 million. So someone thought that this token was worth enough to pay $7 million for, which is just crazy to me, but I don't know, whatever people are into. Often people invest in these in the hope that their price will go up later. But I guess the point is that non-fungible tokens were originally invented for art and games. And one of the biggest ones, or the biggest kind of artistic currencies, was the CryptoKitties, and is CryptoKitties. And this is just like CryptoPunks, but they are cats on a token. So if I go to the catalog, I can see that, say, this token here, this CryptoKitty is currently worth $33 US, just like a CryptoPunk. Now with CryptoKitties, when they came out, it kind of led to a little CryptoKitty mania, and everyone on the Ethereum network was trying to buy these. So it slowed the network down to a halt for a week or so, which was quite inconvenient for people who were trying to get work done. And that's kind of one of the challenges of scaling a blockchain, is that the more people who use it, the slower it goes. Then we also have, just like we had exchanges for our fungible tokens, we also have exchanges for our non-fungible tokens. So something like OpenSea, for example, is a decentralized exchange that's running on Ethereum through smart contracts, and it's trading and swapping non-fungible tokens. So we go to the marketplace, we'll go to, say, all non-fungible tokens. People are putting up these different tokens for sale. So I could buy this artwork here for 0.011 Ethereum, then it would be in my wallet. So I essentially have proof of ownership of a certain artwork. And I can connect my wallet with MetaMask, just like we did to all the other applications. So you can start to see how MetaMask is our gateway into the world of decentralized finance and decentralized applications. Now my wallet's already connected and I can start trading. As part of the kind of non-fungible token craze, oops, sorry, that's a bit rude, that one. We have seen a lot of games that use non-fungible tokens. And you can imagine that they extend beyond just art into digital characters with certain rules and so on. So one game that's quite popular now is called ZED, and this is digital horse racing. So whereas the NFTs that we're looking at just then are kind of a unique artwork each, I'll just mute this. This project uses non-fungible tokens to represent Hi everyone, can you hear me? Sorry, my computer completely crashed when I opened that website, so maybe avoid doing that. I need to be given permission to share screen again, sorry, whoever's the host. How do I see who's the host? Here we go. I'm the host. Okay. Let's get back to. All right, sorry about that. So we were talking about non-fungible tokens, and essentially they're tokens that can't be mixed. They've been used for artworks, for music, and for games so far. But there are also real world use cases which are much more interesting, I think, than doing it for artwork. So for example, what I kind of do for work is apply non-fungible tokens to agriculture. And if we get a chance today, we might not. I'll kind of go through how that looks as well. So you can take wheat, or you can take soybeans, and you can put them on the blockchain and trade that wheat with other people. And you can kind of cut out centralization like that. And you can do a whole host of other things like access loans and finance for your agricultural assets and things like that. So there's also a lot of real world business use cases for these non-fungible tokens. But the important thing to remember right now is just fungible tokens can be mixed and non-fungible tokens can't. Now that we've talked and seen a lot of kind of examples of decentralized finance, I want to start kind of putting us towards the place where we can start to build our own applications. And we'll start with tokens because they're such a in-demand use case at the moment. So I guess the question is, how do we write a smart contract that encodes a token, or that encodes a non-fungible token which can't be mixed, or a fungible token which can be mixed, and has the sort of properties that we're interested in? So you might remember from a couple of weeks ago, we talked about the Ethereum improvement process, which runs through Ethereum improvement proposals. And this is the kind of community's way of, I guess, suggesting changes to Ethereum and deciding on changes to Ethereum. And one of the really cool things that happens as part of Ethereum improvement proposals is people suggest various contract designs. So if you have a great idea for loans on Ethereum, you might want to suggest a standard contract design that everybody who's dealing with loans will use so that all your systems can talk together. So while there are obviously an infinite amount of ways you could write a program that acts as a coin on Ethereum, the community has broadly settled around two different standards. The first one is called EIP20 or ERC20. And this is a fungible token. So you can see that this standard was submitted by two people, Fabian and Vitalik. Vitalik, you might recognize as the creator or the developer of Ethereum. So he's quite big up in the world. This was created in 2015. And pretty much every fungible token that you deal with in Ethereum uses this token standard. So all the smart contracts work the same way. That applies to things like DAI and to Tether, USDC, the Uni Swap token, all of those things. And one of the huge advantages of having the standard is that external tools can rely on that standard to start interacting with the tokens. So MetaMask, for example, we added before both Ether and DAI to our wallet. And if I get my password right, load my tokens, we can see in this wallet Ether and DAI. In fact, MetaMask has been coded to support any fungible token that conforms to this ERC20 token standard. So if we create our own currency, which we'll do today, we can just add that as if it was DAI or as if it was ETH to our wallet and interact with it and send it to other people. So that's really cool. Now, today we'll go a lot more into detail on ERC20 and actually build a contract. But the other standard to keep in mind is called ERC 721. And this is an alternative standard, but for non-fungible tokens. So it's exactly the same, in terms of the community has agreed that this is how non-fungible tokens work. So CryptoKitties and CryptoPunks and the Z horse racing game and so on all use this non-fungible token standard. But we'll come back to ERC 721 a bit later on. What I want to talk about is ERC20 first, and to do that, we'll have to kind of look at some code to start with. So a contract standard like ERC20 is really specifying the interface of the contract. So it doesn't say how the contract is coded, like in terms of how balances are stored and things like that. What it does kind of enforce is the externally available functions that people and applications will be able to call in the contract through submitting transactions to the network in order to interact with it. So you can imagine if 10 different tokens all had a different transfer value function or a different transfer value entry point into the contract, then a wallet wouldn't really know how to interact with each of them. So this standard enforces a common application interface. It's almost like an API for that contract. So you know that if you're looking at an ERC20 token, for example, we'll use DAI, it has all of these different functions available. And we'll go through each of these functions and kind of talk about how it works. And then we'll look at actually deploy a contract that does this. So what we're seeing here is a list of external functions. This is written just in the Solidity language. Solidity is by far the most commonly used smart contract language on Ethereum. And it's kind of inspired by a few languages like C and JavaScript in terms of how it looks, or Java even. So if you're familiar with that, it shouldn't be too hard to pick up the syntax and how it works. If you're looking at these function definitions, we have a few interesting things. We obviously have the name of the function. So here the name is, say, balance of. We look at this one. You've got arguments to your function. So this is what me as a user or MetaMask will actually pass into the smart contract. You've got what the smart contract returns. You've got the visibility of the function. So we'll talk more about that later, but a public function can be called by users of the smart contract as opposed to internally to the smart contract itself. It's just like Java. And for, I'll come back to view in a second, the view keyword here. But let's just first start going through these functions line by line. These are all the ERC20 functions. Some of them are marked as optional, but in practice, everybody implements all of these functions. So first up, you've got name. What this does is it takes in no values and it returns the name of the token. So the DAI smart contract has a function called name, which returns DAI as a string. We have symbol, which can return like a short code in a string for the token. And that might be ETH as opposed to a name being Ether. Then you have decimals, which we'll come back to. You have total supply, which will always return the total amount of that token in existence. So if you have 1,000 KDL dollars, this total supply will return the number 1,000. Then we get into the more interesting function, balance of. And this is how MetaMask knows that I have 10 DAI. We can see it passes in as an argument the address. So it'll be passing in my 0xAA54 address. And then it gets back the current balance that I have of this token, of this smart contract. So it's returning 10 currently. And what all of these functions have had in common are they're all marked as view functions. What that means is that they don't actually change any data in the smart contract. They're viewing data in the smart contract, but they're not changing it. So since we're not changing the data, we don't really need to agree on what's happening in this transaction. So the network as a whole doesn't need to reach consensus on the name. when the smart contract is submitted to the network with its own name value, all the nodes together agree that that submission is correct. From then on, the name value can't change without all the nodes agreeing. So it should be safe for me to always call name without having to check with the rest of the network. What that means in practice is for all of these view functions, I don't have to submit a transaction to the network to be able to get back that value. I can just call the smart contract directly. So I can check the name as many times as I want without paying any Ethereum gas fees or anything like that, without having to wait for my transaction to go around the whole network, and without having to kind of confirm anything with my private key, which is what controls like my identity. And that's why it's so fast for MetaMask to load that balance. We just did that call then. But when we actually want to interact with the contract and make changes, we have functions that don't use the view keyword, and these are ones that you have to submit a transaction to. So the most common function that you would use when interacting with a token is the transfer function. So here we pass in the address that we want to send currency to, and then the amount that we want to send. So that's the to, which is an address, the value, which is an integer, and then it will return true or false whether it was successful or not. And if I were to call this transfer function, which we'll do later, you'd see that it passes up a transaction and it submits it to the Ethereum network for approval to make sure that we have enough money to transfer and that we have permission to move that money and things like that. We also have a slight variant. We have transfer from, and this also lets you supply the address that you're taking money from. So you give the from address, which is say Cadle, the to address, which is say Akia, and then the value that we're transferring. That's all very simple as well. Then we have two more functions. If I want to transfer from someone, either I have to own that address, so that has to be me, as in I'm paying someone, or I have to be approved by them to be able to use their balance. That's what this approve function does. If I call this approve function, and as the address argument I gave, say, Alif, and I said that he could spend up to 1,000 of my tokens, then after calling approve, he could then use transfer from to move tokens from me to someone else without getting my permission because I've pre-approved it. And the reason this function is kind of useful is if you're interacting with a decentralized application that you want to use to manage your currency, you can approve it to start managing your funds for you. So if you're doing like a loan contract, for example, you might approve it to repay your loan later on and things like that. You can check how much you've approved someone to use with this allowance function. And you'll see that it's a view function, so it doesn't require a transaction to create, and it will return how much more they've got available to spend. Then finally, we have what's called an event. So there's functions which allow us to interact with the contract, so either to write to the contract or read from the contract. There's also events which are kind of data that's emitted into the blockchain when you do certain things. And you can look at this data and see what's happened in the smart contract over time. So we can see that we have two events for our fungible token. We have a transfer event, which describes every single transfer that's occurred of currency in that contract. So you can see who it was transferred from, who it was transferred to, and then how much. You can also see every time someone approves another person to spend money on their behalf, you get this approval event. Yeah. If I look at, if I go back to Etherscan, oh, I type, and I go to say, is this DI? I want to go back to the DI contract. Just fine. pull this one out. Here we go. Sorry. So I'm looking at the DAI smart contract now. And what I'll do is I will inspect here. I can go to the events tab. And then I can see those transfer and approval events being emitted by the contract as people interact with it. So you can see here someone has just transferred from this address to this address, and they've transferred a certain amount of money, which is here encoded as a hex string. I can change that to a number. So that much money. And you can kind of see the full history of everything that's happened in the contract. You know, we've also got approvals here. So this address here, this account has approved this sender to move that much DAI, which is pretty insane amount. We can also go to this ERC20 token transactions tab. And because we've got this standardized interface where we have the transfer and approval events, we have the transfer function, we know how this contract operates, then Etherscan can decode all of these transfers and can kind of show it in a nice way. So you can see that these were the transfers that occurred 12 days ago. This is how much DAI was transferred, and so on. If we look at the actual contract itself, so there's a lot of extra stuff here, but if I scroll down, we can see that, for example, that transfer function that we looked at before, this might be quite small on my screen, let's zoom in a bit, is present in the DAI smart contract. So we have that transfer function which takes in an address and a value and does the transfer. And that matches exactly the transfer function in the standard. So hopefully that makes sense in terms of the standard provides the external interface to a type of smart contract. Now, what I want to do is I think now we will all, I guess I'll share my screen. You're welcome to follow along as well. But what I will kind of show is a smart contract development tool called Remix. And we will use an existing token smart contract. We'll get the code for it. I will modify it slightly, and then we'll deploy it to the test network so we can see how we can interact with it through both functions and through the the MetaMask wallet. So to do that, what I'm going to use is a program called Remix. Now, Remix is a web application. It's like an integrated development environment for smart contracts. So if you've used, like in Java, you might have used Eclipse or JetBrains or Visual Studio Code, anything like that. This is a browser-based version of an IDE, integrated development environment, which works for smart contracts. And it's at remix.ethereum.org. And throughout the rest of this course, we'll use this extensively. So it's probably good to get a good feel for how it works today so that we can start to develop our own smart contracts from scratch later on. So immediately we are presented with the welcome page. It's got a bunch of different options, like you can connect it to GitHub and so on. But we'll just kind of use the browser storage for now. So all the contracts that we write will be stored in our browser. They won't be stored to the local disk or anything, so we have to be careful not to lose them. But we can see in this side tab here, we've got the tree of files that we're storing. We've got a contracts directory, which is what we're interested in right now. And we can see all of these files that end in .sol. That's the Solidity file extension. And I can just click on any of them to edit it. And I'll zoom in as well on that. So that's a bit easier to see. So if I click on one, I'll just get the kind of editing window. And what we can see here is pre-populated a really, really basic default smart contract. So we'll go through this one line by line because it's super simple. And I guess next week onwards, we'll talk exactly about how the Solidity language works so that we can write contracts from scratch. But this one should be completely obvious anyway. It's a contract for storage. And the point of it is to store a number in Ethereum. So you might want to store the number 10, right? It's got two functions available. One is called store. You pass in the number you want to store, it saves it in the smart contract. The other is called retrieve, and it returns the number that's currently stored in the smart contract. So once this is on Ethereum, anyone can call store and retrieve and store the number. You'll notice that retrieve here is a view function, so it doesn't require a transaction to use. That's because all it's doing is returning the currently stored number. It's not changing anything. But store, where we're setting that internally stored number to the value we pass in, doesn't have the view modifier, so it does require a transaction. If that makes sense. We also, up the top, we have this little line here which says which version of Solidity we're using. Solidity is a quickly changing language, so they add new features to it a lot. And you'll see that it doesn't. It's currently, if you're familiar with semantic versioning, which is how this system of versioning numbers works, it hasn't yet reached a 1.0 yet, so it's not stable. Each version that you use of Solidity might break previous versions, which is why we specify at the top which version we're using, just to make sure that our contract doesn't break if someone else tries to use it. Okay, so this is our, if we look at this little File Explorer tab, right, this is where we edit our smart contract. And it'll give you standard IDE features, like you've got, should warn me if I make a mistake, right? So here it expected a semicolon, but I didn't put one in there, and so it'll warn me and so on, and it'll do code completion, just like something like Visual Studio Code. So, it's suggesting possible things and so on. So it's a pretty good little editor, like it does the job. And you can also use kind of your local computer for developing. There's a bunch of different tools, but Remix is really good if you're just getting started. So that is the File Explorer tab. Then we go to the next tab here. What we have is our compiler. And this is what's responsible for taking our Solidity code and compiling it down to that Ethereum virtual machine list of instructions that we looked at last time. So if you recall, the Ethereum virtual machine is not actually running Solidity code. It's running what are, really simple instructions like jump, add, things like that. So the compiler has to compile all of this human readable code into that machine readable stack of instructions. Usually we'll just leave this as a default. So we'll say we're using version 0.8.1 of the Solidity compiler. We're using the Solidity language, and we'll just click this compile button here, which will take our contract and it will give us a compiled contract. It's green, so compilation was successful. You can see here, if you click on the compilation details, we can actually see what was created by our compiler. So if I go down to the assembly here, you can see this is the actual code as it will be executed by the Ethereum virtual machine. So again, this is tiny. There we go. So it's got, instead of number equals num, it's got push 80, push 40, so on, right? So if you really want to get into a low level and see the exact instructions that your contract will execute, you can see it here. But most of the time, we just trust the compiler. We don't need to worry about that. Now, the kind of most exciting feature from our perspective is the third tab down. This is what we use to actually test out our contract, interact with it, and then finally deploy it to the Ethereum network. So the first thing to kind of look at, the first interesting feature is this environment dropdown. Now, right now it's set to JavaScript VM. What this means is it's a simulated Ethereum that runs inside our browser. So we're not connecting to the main Ethereum network or even a test network. It's just running the exact kind of logic of Ethereum, but all in this browser tab so that you can test for free and there's no kind of delay in sending transactions or anything like that. And you can just kind of use it willy-nilly. So it gives you a bunch of accounts to play around with. If we look at this account tab, we can change which account we're calling from. So it's pre-funded all of these accounts with 100 fake virtual Ethereum. So you can just stay with the normal one. And you'll see in this contract tab too, it currently contains all the contracts that we've compiled so far. So we've compiled this storage contract. and it's now available in this deploy and run transactions section. So if I click deploy, what will happen is that all that smart contract code that we compiled will be wrapped up into a transaction and submitted to our internal simulated network, and that contract will be added to the network. So with that in mind, we'll click deploy. We can see that because we're running in the virtual machine, that happened instantly. And if we look down in this kind of debug console here, we can see that transaction, and we can click on it to see more information. So firstly, the most important thing to note here is that this is run on the virtual machine. It's not a normal Ethereum transaction. It's all running inside the browser. And you can kind of see all the transaction details if you want, just like on Etherscan. But one of the cool things that Remix does is that now that we've deployed that contract, we can see it here in our sidebar. So we can see the storage contract has been deployed and it's been given this address in the Ethereum network. And if I drop it down, then I have those external functions ready to play with. Looking at our code, we can see we've got the retrieve function and the store function, and they are now present here. So I can actually just click on these and it will run those functions in the smart contract for me. And it'll call on behalf of the account that I've got set here. So the first thing to do is let's click retrieve. Retrieve will return whatever number is stored in this smart contract. And it's a view, so it doesn't create a transaction. So I can just click retrieve. And I can see here in very tiny writing that the result of calling retrieve, it's gone to the smart contract and it's pulled back, and the number that's currently stored is 0. And you can see that all the view functions are kind of highlighted in blue. Then all the functions that require a transaction, so the write to the smart contract, are highlighted in orange. Now, let's say that we want to change the number stored. We're going to use the store function now. So I can see that I've got store, and then I can see what arguments it takes in as well. So if I just try clicking on store, it's not going to do anything because it's waiting for me to pass in a value, the number that we're storing, which I can just type in here. I might say I'm going to store 1,000. When I click on this, and then I scroll down, we can see that it's created a new transaction to the smart contract. So it's now stored that 1,000 in the contract. It's sent that transaction to the whole network, and it's processed it. It's made sure that I've followed the rules. And if I try clicking retrieve again, I can see that the value stored in the contract is now 1,000. Really cool. Are there any questions about that really simple contract? Cool. All right. So there's a few more features that I'll just really briefly kind of point out before. We won't use them yet until later anyway. This integrated development environment has an inbuilt debugger. So if your transaction fails or your code fails and you don't know why, you've got this little debug button, and you can kind of jump into a step-by-step debugger, which you might have used with Java or so on. And you can kind of step through the lines of the code, and you can see the actual Ethereum instructions that have been executed at each line, which is quite handy. So I'll just stop debugging. It also has a feature for writing tests for your code. So if I look at the tests directory, I can see that in Solidity, I can also write unit tests, just like you do in other code, right? So I've got here tests for a contract called ballot, and I can run that with my Solidity unit testing tab, which is this ticks. Then if I go to my plugin manager, which is this last thing, there are also heaps of plugins for interacting with other software in the Ethereum ecosystem and so on. So for example, what's some cool plugins? This RemixD plugin lets you access files on your local computer rather than just in the browser. So you can save your files and use Git to version control them and so on. You've got different smart contract languages like Viper. Solidity isn't the only smart contract language. You could use Viper instead, which is kind of different, but it still works on Ethereum. And you can use different like privacy software and so on. So you can do a bunch of stuff. It's cool. But what I want to do now is look at how we would deploy our own token, our own ERC20 fungible token. And we'll first deploy it to our kind of JavaScript simulated network, and then we'll deploy it to the actual test network so that everyone can access it. So to do that, rather than writing all the code from scratch, what I have is an example contract. So I'll just copy that 1 sec. Okay, so I'm going to make a new contract here, and I'll call it, what are we going to call it? Cablecoin.sol, right? And I've just pasted in this code. So now let's go through it. We can see that what we're doing is implementing an ERC20 token. In Solidity, which again, we'll come back to how all these language features really work. We have something called an interface, which is just like an interface in Java. So it specifies the functions and events that a contract will implement. Here, these are all the ERC20 functions that we saw in the standard. So things like transfer and the event transfer, event approval, and so on. Then we actually have the implementation of these functions. So this is in that contract. The contract is called ERC20 basic. You can think of a contract as pretty much a Java class, right? It's like an object that gets deployed onto the blockchain, and then people can interact with it through public functions. Up the top here, we have firstly some constants that describe data about our smart contract. So we can see the name has been set to ERC20 basic. We can change this to anything we want, and let's call it Cablecoin. You can see the symbol, and this is kind of the short, usually 3 or 4 letter descriptor of this coin, which will show up in things like wallets. So let's call this maybe CAC for Cablecoin. Then decimals is a bit more interesting. You could theoretically store, oh, sorry, let's rewind a bit. The data that's associated with a fungible token, so one that can be mixed, is really nothing more than a list of people and a list of how much they own, right? So in the database that kind of manages our currency, it really might just look like Cadle owns 1,000 tokens, Aleph owns 2,000, and someone else owns 10,000, right? That's really all the data that we need. But if we just had that structure, like Cadle 10,000, what if I wanted to transfer, say, half a coin? Then in a language like Java or something like that with floating point values, you could send, say, 0.5 of a coin. And then I would end up with like 999.5. But in Solidity and on Ethereum in general, we actually don't have these floating point values because they're, I think, technically they're a bit difficult to implement at the time. So we can only deal with round integers like 10,000. So I could send up to like a minimum of $1, right? I couldn't do the 0.5. So to get around that, what we do is instead use something called fixed point. So that looks like this. It's not a particularly useful wiki page, but just to say the name, fixed point arithmetic. And what that means is that if I have 10,000 coins and I want to represent it down to 2 decimal places, what I'll actually do is add 2 more zeros onto the coin. So it looks like this. Then if I want to transfer half a coin, I would send, say, the number 50, which then results in me having 999.50. And if we put back in the decimal place, then we get my final balance of $9,999.50. Right? Hopefully that makes sense. Look up fixed point arithmetic too if you want to get familiar with this. But what this decimals constant here is saying is that we're going to have our current balance, say 9999, and then we're going to represent it to 18 decimal places. So if I have have $7, right? I've got $7 worth of tokens. It will actually be represented in the code as 7 with 18 zeros after it. Like that. Hopefully that makes sense. So after we declare those constants, which kind of describe information about our coin, we then have the data section of our contract. And this describes the information that is stored on the blockchain. So rather than the functions that you use to modify and read the data, this is the actual data itself. So kind of the most obvious point of data, we've got this variable called balances. And this uses a mapping. So it's like a dictionary in Python or a hash map in Java, I think it's called. I'm not sure, I'm not really that familiar with Java. But essentially this takes an address and maps it to a number. So this is where we store our balances. Now our map might look like Cadle points to $9. Bob points to 1,000. Right, this is our balances. We also have here the total supply, so the maximum number of tokens in our smart contract. And we have another variable that allows us to store those permissions that we've given to other people to spend our currency. So then we have our constructor. So this in Java is like I think it's also called a constructor in Java, I'm pretty sure. But you know, it's the function that runs when you create the contract. So when I create this ERC20 token, the Cadle coin, when I deploy it to the network, I have to provide a number which will be the total supply of the contract, and it gets stored in the contract here. We set the total supply state variable to be whatever number I passed in, and whoever created the contract gets that as their balance. So whoever creates the contract starts with all of the tokens. Then we have the implementation of all of those ERC20 token functions. So we'll talk about them, but you know, something like balance of, right, is really easy. All it does is it takes in an address, it looks it up in that balances mapping, and it returns the amount that someone has. Okay, so now let's take this contract and we want to deploy it to a network. So the first step is to compile it. We'll go to our Solidity compiler and we'll just click the compile button. We've seen there was no errors, got a green tick, and our contract is now available here. And we can see that's the ERC20 basic contract, which is what I call it here. I might, just to make it clearer, call it Cadle coin, and then I can recompile it. So I've got that, the contract will be named Cadle coin, just so that we're not confused. Then what I'm going to do is I will deploy it to the JavaScript simulation running in my browser. So I'll just minimize the other contract that we created. Expand this a little bit. If I click the deploy button, it's not going to work. So what it said is the creation of Cadle coin errored. There was an error encoding arguments. Essentially, we're missing our total value. So in Cadle coin, I can decide how much of the token that I want to create. I'm going to say that the total amount of Cadle coin in the whole world is $10,000. So that's 10,000. And then remember, we're going to 18 decimal places. So I'll put 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so this is now 10,000 Cadle coin. I've clicked deploy, and this time the transaction was successful. And we have a new deployed contract called Cadle coin at this address. Expanding it out, we can again see all of those functions that are specified by the ERC20 interface and which we've coded for, like we've implemented, and they are all available now. So I can look at the name and get back Cadle coin, or I can look at the symbol and get back CAC. Total supply is then that 10,000 and so on. Let's have a look, say, at my balance. So since I am the creator of the contract, and looking in the constructor here on lines 34 to 37, we can see that whoever creates this contract, their balance, or the balance of the sender, is equal to the total supply of tokens. So I should start with everything. And we can confirm that by using the balance of function, which takes in an address and returns the balance that that person holds, so the amount of currency they hold. The simulated address that I use to send this is up here. I can just copy that really easily. I'll paste it in as my argument to balance of, click balance of, and we can see that I have all of this money here. Now, out of interest, I'll just check that other people don't have any money. So I can switch to, say, a second account, 0xAB8, and this person should have a balance of 0. So I'll put in their address, and we can see they've got a balance of 0. Cool. So now what I'm going to do is I'm going back to my main account. So my balance will be 10 gazillion or whatever it was. And now I'm going to start transferring some money to another person. I can use the transfer function for that. And if I have multiple arguments to my function, I can just drop that down with this little button here. And that will make it a bit easier to paste things in. So I'm going to send some money to the second address here. I'll copy them in as the receiver value. So this address will receive the tokens. And maybe I'm going to send a tiny amount of tokens. I'll send 1,000 of my tokens, which is probably, what's that? Something like 0.0000000000001 cattle coin. I remember because this is to 18 decimal places. And it's really easy. I just click transact. It'll bundle that up into a transaction and it will submit. And we have a reversion. Why is that? Okay, so what we've got here, and I'm not quite sure why yet, is we can see that our transactions failed. So this is the Ethereum blockchain, working as intended, right? Because we've broken the rules somehow, we've broken the rules of this contract, it has reverted our transaction. It said that that's breaking the rules and it's rejected it. So now, as the developer, we want to work out why that's happened. I'm not entirely sure why. Let's kind of do some debugging here. So I'm calling from this account, starting with 5B, like this is me on this fake Ethereum network. So firstly, I'll just check that I have enough money. So check my balance, right? I should have enough there. And I want to send 1,000 of that to them. So that should be okay. Why does that fail? Okay, so we're a bit confused here, or I'm definitely confused. What I'm going to do is click this debug button, and it will help us work out why this transaction failed. So if we look here, we can see where we're currently at in the contract. So it's kind of tracing the execution of that transaction. And I'm just going to kind of step through all of these buttons. So if I click step through, I can see the lines change. We're executing different instructions and they're running on the left. So I'll keep clicking through. So we've passed the first check, which is saying that we need to have that many tokens to be able to interact with it, to be able to send it. So I can't send like 10,000 tokens where I only have 1,000. Now we're going to do the actual transfer. Takes quite a while. Because there's lots of tiny little instructions associated with this, like human readable code. Okay, we're up to the next line. Oh, okay, so we've hit a problem here. 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 So we've hit a problem Aha, okay, so here's a bug in our smart contract. So what's happened here is the contract won't let us go any further, right? And if we look at, we might be able to see reversion, I'm not sure. Essentially, like at some point here, we've now hit an illegal instruction. And if we look at the code of the transfer function, we can see why that is. So the logic of the transfer is really simple. We want to, if I'm sending 1,000 tokens, we want to subtract 1,000 from my balance and then add 1,000 to the receiver's balance. But in this contract, whoever wrote the contract has put a minus sign instead of a plus sign. So when the receiver has $0, like they currently do, and then we try to subtract $1,000 from that, which is incorrect, it should be plus, we're getting an error because balances can't be negative. So that wasn't even deliberate, but that's actually quite cool. So let's change that to a plus, right? That should fix it. So the debugger has helped us work out the problem there. This logic should be correct. What I'll do is recompile Cablecoin, and I'll deploy a new version of it to test it. And I'll just delete the old versions so that we don't get confused. Then I'll say 10,000. Now what I'm going to do is try to do that transfer again. So I'll copy the address of the person I'm transferring it to. I'm going to send them 1,000, click transact, and there we go. So we can see that we're successful now. Cool. I was getting a bit worried there. If we check the balance of the person we transferred it to, we can now see they've got 1,000. So that's worked. And I would encourage you all to, this week, open up Remix. I'll put a link in the WhatsApp to a sample ERC20 token contract. So try out creating it or putting the code into Remix, compiling it, and then deploying it to the JavaScript virtual machine environment. And then kind of interacting with it through these functions. So you get a good idea of how the contract actually works, like how tokens work. Okay, now there's one more step before we wrap up for the day. What we want to do now is we've developed our smart contract, we've found that bug and we've fixed it, and we are now ready to submit it to the Ethereum network for other people to use. So not just our kind of in-browser simulation. To do that, what I'm going to do is change my environment to be injected Web3. Now, this hover tooltip, which I hope you can see, is a lot more helpful than when it says injected Web3. What it says is that the execution environment, so the environment that our contracts run in, will be provided by MetaMask, our wallet, or another kind of gateway into Ethereum. So if I click injected Web3, I get this little MetaMask pop-up, and it's asking me to connect to Remix with my actual test account. So I'll allow that. We can see that we're now connected to Ropsten, that test network. And this is our actual account, 0xA5, which we can see here. So now we're no longer in the JavaScript virtual environment. We're no longer running just in our browser. We're now connected to the actual test network. And if we switch this to the Ethereum mainnet, we'd be on the actual Ethereum mainnet and we can interact with it. So if I'm going to do the same thing, I'm going to deploy my contract, but this time it's going to be to Ropsten. So I click deploy. Now, because we're going to an actual network, I get asked for a bit more extra information by my wallet. It wants to know how much gas I'm going to pay, how much data I'm going to send along with it. We can see that this is a contract deployment transaction, and I can set my gas price, which I'll just bump up again to make it go a bit faster. So if I confirm this transaction, we'll see that it will take a bit. We've got down here a little message that says that the creation of Cablecoin is pending. Because we've gone to the actual network, it takes a while compared to the virtual machine, because this is going to actual other machines around the world. But there we go, it's worked. So it was included in this block here, and it's deployed just like our virtual contract, but it's deployed on the blockchain rather than in memory. So this is an actual contract now that we've deployed to the test network. And if I expand this transaction, so more useful, see here in this deployed contract section, we have the address that the contract was deployed to. In our virtual environment, that doesn't really matter. We didn't care so much about the address, but in a public network, if people want to use our token, they need to know that address so they can interact with the contract. So it's a lot more meaningful now. We can just click this copy icon, copy that value to the clipboard. And now if I go to Etherscan, I can paste in that value and I can see my contract on the public test network. So I'll just switch first to the testnet for Etherscan. I'll type in that contract address. And here we go. I can see this is a contract. It's deployed to this address here. And there's been a single transaction to it, which was me creating it, so the contract creation. Since this is public, any of you could go onto this, connect to your wallet, and you could start interacting with my contract as well. So whoever created, say, the DAI contract for the DAI stablecoin, they went through exactly the same process. They deployed it to the Ethereum network. Then they shared that contract ID with everyone else, that address, so that people could start to use DAI, so on. Now, because we implemented this token according to ERC20 and that ERC20 standard, I automatically get access to all the tools that are built to conform to that standard. One of those tools is MetaMask, and it's got a really cool feature called Add Token. So if I copy the address of this contract, I can go to Add Token. I can put in the address of the token. It's going to call that contract and it'll automatically find out the symbol, CAC, for Cadle coin that we put in. And I will click Next. I'll go Add Tokens. And we can see that this now appears in my wallet. So my CAC balance is now in the wallet. It's really cool. So we can see that we've got a very tiny amount of CAC. Then I could just transfer that to a Leafs account, for example, from last week. So I can actually do that now, right? I don't know how much I've got available, but let's say like that. And you confirm that transaction. And that's actually called the smart contract on the test network. It's submitting the transaction and it has been sent. So let's just see if that's come through yet. It might take a little while. Did that work? A transaction has been confirmed. There we go. So now we can see that someone, who is me, we know that, has called the transfer method on that public contract using the MetaMask interface, and they have transferred to someone else. Right, so you can see all the public transactions that have occurred on this contract. So we have 15 minutes left. Are there any questions on that? I know that was a kind of huge dump of information, and I'll send some links that will be helpful to understand it as well. But are there any questions for now? Okay, cool. So what I would like you all to do this week as sort of a kind of check for understanding is if everybody, I know Alif's already done it, so I've got his. Oh. Sorry, did someone want to say something? Yeah, cool. So if everybody could install the MetaMask wallet and connect to the Ropsten test network, and then copy their address like this and send it to me in the WhatsApp group. So just paste your name and address in WhatsApp in that student group. Then what I'll do is I will send everybody a certain amount of Cadle coin. So everybody will have, a tiny amount of Cadle coin. And then I'll get everybody to make at least one transfer of Cadle coin in the public contract. And then next week we can check that everybody's transfers went through. So we make sure that everybody knows how to connect to the contract and interact with it. And then if we run into any problems during the week, we can kind of talk about how to resolve those problems next week as well. So the first step is set up your wallet, and that is at metamask.io. And I'll send this link in WhatsApp now, actually, before I forget. Cool. So I've just sent that link in WhatsApp too, so you've got it available. And then, yeah, send me your address, which you can copy from the wallet, and then I'll start sending you some Cablecoin to play around with. It's also good, you know, if other people post their addresses, you can also try transferring Ethereum to your address as well. And if you recall, the test Ethereum is free. To get it, you have to go to something called a faucet, and you can just search Dropstem faucet, and I'll send this link as well. And you can click this request 1 Ether from faucet button, and your account will be credited with 1 Ethereum to start transferring around and things like that. Okay, cool. Any more questions before we finish up?
Cadel, I had a question.
Yep.
The language Solidity, it's based on which languages? Java and?
So it's inspired by, I guess, Java and JavaScript and C. So okay. It kind of takes elements from all of them, but if you've done any imperative language like that, it will all make sense. And next week we'll go through an introduction to the language itself. If you're interested, just search like Solidity language and have a look at this documentation website. It's pretty good. You know, they'll talk. There's some examples.
Right. Well. Yeah. Okay. Thanks. Cool. So next week we'll be starting the main implementations, that is on how to create actual applications, right?
Yep, exactly. So we'll come ready for coding next week. So make sure you've got your wallet installed and you've tried to open Remix and maybe deploy a contract.
Right. Got it.
Okay. I will stop the recording.